On the left we have Visual Studio 2022 with C#10 and .NET 6, and on the right we have 2022 Preview with C#11 and .NET 7. We can run these two apps and see that they work fine. The first feature we'll look at are Newlines within interpolated strings. Imagine we have a class like this, channel, list of subscribers and so on. So the first thing we do is have a variable for our channel, new channel, very good. And then we want to do console.writeLine with $, for the interpolated string. The first subscriber was channel.subscribers.first. And we can see that that is pretty long. That is a pretty long string and it's going off the screen, which isn't great. We can also do writeLine, this channel has subcount subscribers, like so. Now that's cool, but if we wanted to do new lines in here, C#10 is going to complain. We are not allowed to do this. However, if we take all this magic over into C#11, let's get that class in, copy and paste all this stuff in, we will see that C#11 allows you to do new lines within the holes of interpolated strings. Let's take a look at list patterns. Imagine we wanted to get a variable saying Gary, the first subscriber. We could use link to do this by doing channel.subscribers first Gary. And we do console.writeLine. Gary was the first subscriber. Very good, run the app, and it says true. So far, so good. If we wanted to do this in C#11, this obviously still works, so we can copy this code over, and it works a treat. But there is a smarter way of doing it. We can use list patterns. If we do channel.subscribers is Gary, and run the app, we can see that it's true. So what if we wanted to have a Boolean variable that said Gary was first and Steve was last? We could do this with link, obviously, like this, channel.subscribers.last Steve, run the app, and it says true. Very good. But with list patterns, we can be cleverer and go channel.subscribers is Gary, Steve, run the app, and this also says true. Very cool. Now imagine we want to get a list of the subscribers between Barry and Steve. We could do this with link. We could do this with getRange. Kind of looks a little bit like this. Not very nice. And if we wanted to write this list out to the console, we would do something like this. Let's add another subscriber. Let's call them Dino. Run the app. Bang. We get Nigel and Dino. They subscribed between Barry and Steve. Now, if we wanted to do the same thing over here, we'll add Dino to our list, and we can do something a little bit special. If you change your list to an array, despite the name list patterns, this particular trick doesn't work on lists. There you go. Very good. So we can do something like the following. If channel.subscribers, and using our list patterns, we can do this. Barry var subscribers between Barry and Steve. We'll use that as the variable name. Steve at the end. Very good. We can see here that we've captured this pattern here. So there is now an enumerable to loop through. And if we run the app, we can see that Nigel and Dino have been captured from the list pattern. Very nice. Imagine you have a bit of JSON that you'd like to embed in your C# code. In C#10 and .NET 6, you would do this, and immediately it will start complaining, because if we want to write a line with the JSON out like that, this code will not compile. The way to fix this in C#10 and .NET 6 is to put all of this on a new line, like so, and put the @ symbol there to indicate that this is a string literal. However, you also then need to go and double quote all of the quotes in your JSON like this, like so, and eventually, after faffing about, C#10 and .NET 6 will allow you to run this program and print out the JSON. However, over in C#11, we can do this slightly differently. So if we do var JSON equals our JSON here, and do console.writeLine JSON, the solution to this problem here is to use a raw string literal. To do that, you will do a $, and 3 quotes, which indicates the start of the string literal. And you put the 3 quotes here on its own line, and that's it. Your JSON here is exactly the same as the stuff that you've just pasted in. And now you can run the code. Very good. The reason it's important to have 2 $signs, It's because if you delete one of them, it will start complaining because the interpolated expression starts with a curly bracket. If you put a second $sign in, this means that to do an interpolated expression, you would use 2 curly brackets. So for example, we can do subvar subcount is 3000, and then inside your raw string literal, you would do a double curly bracket, and you'd be able to type subcount like that. Hit run, and it has put in the 3000. Very good. That was a short intro to raw string literals. Let's take a look at auto default structs. Consider the following struct. We have public struct channel info, and we do public int subscribers, and we do public int likes. And if we do something like var info is new channel info and console.writeLine info.subscribers and run the application in .NET 6, we get a 0. So far so good. However, in C# 10 in .NET 6, if we create a constructor called channel info, we are forced to initialize both subscribers and likes here. The compiler is saying that field channelinfo.likes must be fully assigned before control is returned to the caller. So this won't let us run this app unless we also do something like this. So we have to initialize both of these values in a struct before we're allowed to use it, which can be quite limiting. However, over in C# 11, if we take our code here and paste it into C# 11.NET 7, we can see that the constructor will now allow us to partially initialize this, whereas over in C# 10, this is an illegal constructor. So there you have it. In C# 11.NET 7, we have auto default structs. Pretty useful. Next, let's take a look at UTF-8 string literals. Imagine we had a string, such as var name Ted. If we wanted a byte array of this in C# 10.NET 6, name bytes, we would need to do something like system.text.encoding, UTF-8, get bytes, name. Now this would be evaluated at runtime, which isn't awesome. If we wanted a read-only span, read-only span of byte, name span, we can do this as well. However, both of these are evaluated at runtime. Believe it or not, to have name bytes here set at compile time, you would have to create a byte array with the character values in. Yes, in C# 10.NET 6, this is what you'd have to do. However, in C# 11.NET 7, there is a better way. If we revert all of this and take our code over here, if you wanted to do this at runtime in C# 11, you can literally now just type your string in like this, and this also applies to read-only spans. Very good. The code on the right is not valid in C# 10. As you can see, the compiler here is not having it. Those are UTF-8 string literals in C# 11 and .NET 7. Fantastic. Let's take a look at switches on read-only spans. Imagine we had a function here called static bool is Ted that took a read-only span of byte. Call this span. And in here, to do a switch statement, we're not going to be able to do that. So we're going to have to do a series of ifs. So if system.text.encoding UTF-8.getString span equals Ted, return true, and we'll do another one here, ed, return false, and we can run this app in C# 10 and .NET 6, like so. Obviously, we can then do console.writeLine is Ted with the name span. Very good. Run that. Look at that. True. Happy days. However, that is really horrible, and we're converting from runtime to compile time frequently. Over here in C#11.NET 7, we can take our code. We can convert these to constants again, like so, which is great. Let's change this read-only span to a span of cars. And if we take our method from C#10, paste it in here, change that to a car as well. Very good. And we can change this now to a switch statement, which I think is pretty cool. So we can just do switch span, case TED, return true, case head, return true, and do default return false. And this code will now work. We can take our line of code to write it to the console and run the app. And that is much nicer. Very nice. Gets even better though. You can also do a return switch statement. So let's comment this out or delete it. That's much better. We can do return span switch like so. TED true, head true, and default through to false. Bung a semicolon on there, and this will now run. Very nice. That was a quick demo of switching on read-only spans of cars. Pretty cool. Thank you for watching. If you found that useful, you might want to watch another video in the series, or even click on my face and subscribe for the next time I make a video like this. Cheers.